Welcome back to the Deep Dive. We've got some fantastic source material from you all, and today, well, we're digging into something truly special. The dinosaur, Borealopelta.
Yes, and we're not just talking about, a few scattered bones here. The scientific papers describe something, well, almost unbelievable.
It really sounds like it. This isn't your average fossil story.
Yeah.
We're focusing on Borealopelta, which means Northern Shield. A fitting name, as we'll see.
Definitely. And it lived during the early Cretaceous period.
The real hook, though, is this specific specimen found up in Alberta, Canada. It's just
Frankly.
exceptionally preserved.
It really is. Think skin, armor, even its last meal. It gives us a snapshot of life over 110 million years ago like almost nothing else.
So set the scene for us. Where did this discovery happen?
Okay, so picture this. 2011, an oil sands mine near Fort McMurray. A heavy equipment operator, Sean Funk, well, he hit something hard.
Okay.
Initially, because of the geology of the area, these are marine sediments, they thought maybe, some kind of ancient marine reptile.
Which would make sense, geologically speaking.
Exactly. But it wasn't.
Here's the twist.
It turned out to be a land-dwelling dinosaur. An armored one. Imagine the shock, the excitement in the paleontology community. A nodosaur found out in the ancient sea.
Wow. Okay, so this Northern Shield, let's place it on the map. Where does Borealopelta fit in the grand scheme of dinosaur evolution?
Right. Scientifically, it's Borealopelta markmichelli. Brown and his colleagues named it in 2017. Its classification goes all the way up, Eukaryota, Animalia, Chordata.
The usual suspects.
Yeah, down through Dinosauria, Ornithischia, that's the bird-hip dinosaurs, then Thyreophora, the armored ones,
Okay.
then Ankylosauria, and specifically the family Nodosauridae. And even a subfamily Nodosaurinae.
So Nodosauridae, that tells us something specific, right?
Yeah.
How is it different from, say, the famous Ankylosaurus?
Good question. They're related, both armored ankylosaurs, but they're in different families. The big difference people often point to is the tail.
The tailed club.
Exactly. Ankylosaurs often had those big bony clubs. Nodosaurids, like our Borealopelta here, they generally had a straight tail, no club.
Interesting. And within the Nodosaurs, where does it sit?
Well, the analysis places it as more derived, sort of more evolutionarily advanced, you could say, than something like Nodosaurus itself. It actually clusters with other nodosaurs from around the same time, the Albian stage of the early Cretaceous, things like Papasaurus and Unearthed.
Okay.
The next closest relative seems to be Hungarosaurus, so it gives us a really nice picture of nodosaur diversity during that period.
No tail club, but still sounds pretty well defended. Let's really try and visualize it. What did it look like?
It was a big animal, about 5.5 meters long, maybe 18 feet, and weighing around 1.3 metric tons, so quite stocky.
Hefty creature.
Definitely. But the truly mind-blowing thing is the preservation.
Mm-hmm.
We're talking three-dimensional. The armor, the osteoderms, those bony plates, they're still there, in life position. With the keratin sheaths that covered them, the skin patterns underneath, even some soft tissue. And it's not flattened like most fossils or shriveled up like some dinosaur mummies.
So it's almost like a statue, preserved in the round.
Pretty much, yeah. It's incredible. It gives us such a clear view of its armor. Rows of small, bony plates packed closely together all over its back and sides.
Like a shield, hence the name.
Precisely. And sticking out from the shoulders were these two really prominent long spines, almost like bull horns. Very distinctive.
You wouldn't want to bump into it, that's for sure. Now, with this level of detail, did they figure out its color?
Amazingly, yes. They looked at microscopic structures called melanosomes, which hold pigment preserved in the skin scales.
Yeah.
The analysis suggests it had a generally reddish-brown, maybe pinkish skin tone. But here's the really unexpected part.
Go on.
They found evidence of countershading.
Countershading. Like on sharks or deer? Darker on top, lighter underneath?
Exactly that. It's a form of camouflage. Helps an animal blend in by reducing shadows and making it look flatter, less conspicuous.
That's a huge armored dinosaur. Why would it need camouflage?
That's the million-dollar question, isn't it? It strongly implies that despite its size and all that armor, it still had predators to worry about. It wasn't invincible.
Fascinating. So who might have been hunting it?
Well, there were large predatory dinosaurs around back then, big theropods. Even with armor, maybe younger or isolated individuals were vulnerable. It really paints a picture of a dangerous world.
And those big shoulder spikes.
Just defense.
Probably defense, yeah. But the researchers also suggest they could have been for display. Attracting mates, recognizing members of the same species. Maybe a bit of both.
Defense and display. Makes sense. Okay, let's shift to what fueled this northern shield. What was on the menu?
Again, the preservation gives us gold. They analyze the contents of its stomach. Its last meal, essentially.
What did they find? A belly full of everything. Actually, no. It was surprisingly specific. The vast majority, like over 80%, was ferns. Specifically, certain types of ferns.
Just ferns.
Really, seems like it. It suggests Borealopelta was quite a selective feeder, not just mowing down everything in its path.
That does challenge the image of giant herbivores just constantly eating whatever's around.
It does. And there was something else interesting. About 6% of the stomach contents was charcoal.
Charcoal, like from a fire.
Exactly. The interpretation is that it was feeding in an area that had recently burned, perhaps taking advantage of the fern growth that often follows a fire.
Huh. A post-fire specialist, maybe?
Possibly. And based on the growth stage of the ferns, they think it died sometime in the early to midsummer. A 2023 study reinforced this, comparing the gut contents to the known plants of the Gates Formation where it likely lived, suggesting it really was zeroing in on those ferns in a recently disturbed area.
Such specific details from millions of years ago. Okay, the big question then. How did this land-dwelling, fern-eating dinosaur end up fossilized way out in marine sediments?
Yeah, that's the geological puzzle. It lived about 110, 112 million years ago at the Albian stage. Back then, a huge inland sea, the Western Interior Seaway, covered a lot of central North America.
Right.
The specific rocks it was found in, the Wabisca member, were laid down pretty far offshore in that sea.
So it definitely didn't live there.
No, almost certainly not. The best explanation is that it got washed out to sea, probably died on land near a river system, and then got carried out during a large flood event.
Swept out into the ocean.
Yeah.
Poor thing. Didn't float for a while.
That was an early idea, the bloat and float hypothesis. Body decomposes, fills with gas, floats upside down for a bit, then sinks.
Makes sense.
But maybe not for these guys. Ankylosaurians were dense, heavily armored, stocky build. It's now thought they might have been too dense to float for very long, if at all.
So what's the current thinking?
The more likely scenario is it was washed out, probably alive initially, struggled near the surface, drowned relatively quickly, and then sank.
A much quicker and maybe more grim end. But how did that lead to such perfect preservation on the seabed?
Well, sinking likely happened relatively fast after death. It probably landed upside down because they were likely front-heavy. It hit the soft seafloor hard enough to make an impact crater, pushing the mud aside.
Okay.
Then, crucially, sediment quickly covered it. We see evidence of water escaping the mud around it, suggesting rapid burial. This protected it from scavengers. The body cavity filled with sand, helping maintain the shape, and then the key step. Minerals in the surrounding sediment, specifically iron carbonate, started to precipitate out and form a hard shell around the body, a siderite concretion.
Like it got encased in natural cement.
Essentially, yes. This concretion formed relatively fast, geologically speaking, locking the body in place, preventing decay and compression, and preserving everything in stunning 3D.
An amazing, if rather unlikely, sequence of events. A tragedy for the dinosaur, but a jackpot for science.
Exactly right.
Let's circle back to the discovery itself. Sean Funk, the excavator operator at the Millennium Mine. That collaboration seems key.
Absolutely crucial. Without him recognizing something unusual in Suncor Energy, being willing to halt operations and call the Royal Tyrrell Museum, this specimen could easily have been lost forever.
It must have been a massive job to get it out.
Oh, hugely challenging. Museum crews needed mine safety training just to get on site. The main block was high up a cliff face. It took about 14 days of careful work by museum staff and Suncor employees.
I heard the block broke during the lift.
Yes, unfortunately, the main piece fractured as they were lifting it. But the team was prepared. They managed to wrap and secure all the pieces for transport back to the museum in Drumheller.
And that's when the really painstaking work began.
That's right. Enter Mark Mitchell, the museum technician. He spent, get this, nearly 6 years meticulously chipping away the rock, grain by grain almost, to expose the fossil.
6 years.
6 years, over 7,000 hours of work. It's an incredible feat of patience and skill.
No wonder they named the species Borealopelta Mark Michelli after him.
Absolutely, a fitting tribute. And thanks to his work, the public can now see this incredible find at the Royal Tyrrell Museum. It went on display in May 2017, part of their Grounds for Discovery exhibit.
What an amazing story from start to finish. Just think about what this single fossil tells us.
It's phenomenal. We get its appearance, the armor layout, skin color, evidence of camouflage.
Its diet. what it ate for its last meal, the environment it was in.
Even the exact circumstances of its death and fossilization. It's an unprecedented level of detail for a dinosaur like this.
And it really does challenge our preconceptions, doesn't it? The camouflage on this armored giant, the selective feeding, it shows there's still so much we don't know.
Precisely. It highlights that even animals we think we understand, based on more fragmentary fossils, can hold surprises. Borealopelta is a testament to that.
It really makes you wonder, doesn't it? This discovery relied on such a specific, rare chain of events, the death, the transport, the rapid burial, the mineralization, and then being found just so. How many other stories like this are still locked away, maybe just beneath our feet, waiting for that lucky break?